a bit frazzled apparently. Okay, I will do both. So it's going to be recorded and the screen is now shared, hopefully. Okay, so we have the access modifiers here. You can see there's public, protected, package / default, and private. Now, roughly to kind of go over them, public, right, is kind of what you can think of as like, the least exposed. As you can see here, everything has access to it. It's basically just like what you would do if you want other people to use your classes and your methods. You would define them as public, right? Most functions will be public, probably around 60 to 70%. When you're starting off, as you kind of develop more and more, you'll find that you use public less and less, which is good. Protected is what we're going to be talking about in a second, right? But it's like less. It's like more intended for subclasses. That's kind of like the big indication around it. And then you got package or default. That basically what happens if you don't specify anything. If you just say, void main, for example, it's going to be a package function. And again, that's kind of indicative that it's related to the package. And then private, obviously, is just like if you have private thoughts or you have a private class, right? It's the same kind of idea, right? It's should be less exposed. So if I bring the equivalent to Google Sheets, and this just loads it from the Sheets, just so it means I can modify it and updates. And we can kind of just go through and talk about some of these things. So I'll do a poll for some of them, but some of them we won't, just because I kind of want to see what people remember. Hopefully they've covered this in lectures. If you haven't, a good guess is still okay. So for example, as I talk about, this one's package default. So I presume most of you can kind of guess that it's going to be visible within the same package, right? So anything that's with the same package, it should be visible, right? Those ones, fine. And then we private here. Yes. Yes, it was done. Okay, and then yes. And then what we have over here is that we have private, which hopefully some of you can maybe think about and go, well, how much access is private going to have, right? Well, if it's private, it's like just that class, right? So these are all going to be no for private, right? These are the ones that I think probably most people can reason about okay. And then we have over here protected, which is kind of where it gets a bit iffy, but again, I talked about subclasses, so I presume these subclasses here make some sense, right? So protected is all around subclass. So why don't I just make this a bit more clear? So protected is around subclass. Private is like what we would call the most restrictive. Plus, I think strongest is sometimes the term it uses. So we'll do that, and then we'll make this, and then this is going to be the least restrictive, which we're not actually going to put just because we don't have enough space. Now we have a few empty spaces here that are a little bit more tricky, right? And so the first one is whether or not protected can access any class in the same package. And then the next one is whether or not protected can access any class in any other package, for example, and then for package default, the same kind of idea. So we're going to begin with the protected can access any class, same package. And it's a yes or no. It's anonymized. So feel free to don't really care if you get it wrong. Who cares? Okay, so looks like about yes is the surrounding answer, and the answer is yes. So protected is this is a bit weird. So this differs from most languages. Typically, most languages protected just indicate subclass, so only the subclass can access it, which is really, really useful, right? Because you sometimes want to like basically have something that's private, but you want the subclass to like override it or like add unique behavior, right? But in Java, that doesn't work that way. In Java, this is the one super important one. Most people don't. forget, right? Then this is yes, right? Now, any class and other packages is going to be a no, right? So it's basically just package default with one extra rule, which is this one here, right? Package default is no, no. So kind of the rough way I remember it is like a staircase. Oh, I remember it as the only one I ever remember is private and public, basically. And then package as well, right? Because package, private, and public are the easiest ones to remember. And then, I mean, and by now I've done so many times in classes, I just remember this. But like when I couldn't remember protected, and like in the final exam and stuff like that, because we couldn't bring anything in. I just try to like remember the private tree and the public tree, and then package I could figure out pretty easily, and then protected was just the same thing as package, right? With one change. I don't know, maybe that's just not useful. Thinking about it again, it seems a bit convoluted way of thinking about it. Anyway, so we can reload the page and see if it reloads the data properly. Yeah, it does. It's awesome. Okay. So now that's done, we're going to talk about inheritance, and more specifically, we're going to talk about shapes and stuff like that. And I will mention livscovs, but that's not really livcovs, but that's not really the intention of today. So let's open up our Visual Studio. And we're going to go to example, open up our rectangle, and we're just going to kind of have a rough around with the shape and just try to like have some kind of inspection side of it. So obviously, by the way, a lot of you watch the tutorial. If you have any questions about the tutorial, please ask and I can cover them. I'll probably cover most of them just by what I do, but if there's any specific questions, please feel free to ask. You can raise your hand and I'll stop and then let you speak. Or you can just like write it in the chat. Either one's fine. So if we have a shape here, our shape is going to be defined basically in terms of two things. The first thing is we're just going to have a color. Now we're stating this this member here, this data member or field. We're stating it's private because we don't want to expose the implementation of what color is. And so this is quite important because effectively color itself may be stored in many different ways. And so an example could be we come on later on and we decide that we want color to be more than just like red or blue. We now actually wanted to have like an hex code. So for example, red would be like OXFF0000, right? Because we got RGB, right? As a simple thing, with white being or Fs and black being or zeros. These are just like, you don't have to remember these. These are just color codes. If you've done any design work before, you remember them. And so we may want to implement it via something like this, or we may want to implement it via, there's many other metrics like CRGB, or no, there's something else. I can't think of right now. And there's also other things like talking about the luminosity and brightness of a color rather than specifically the three channels. And so when we want to do stuff like that, we may want to change what this color is. And so we want to try to like hide this implementation detail of what this is as much as we can, because it allows us to make changes without impacting other files, right? And so it's the property of encapsulation effectively, or literally. And so the next thing we can do is we can define a method called getArea. And now what this method here is going to do is it's just going to grab the area of the shape. So for example, a square would be the width times the width, right? Because obviously a square is defined as having the same width as its length. A rectangle would have a different width and different length. And what we're going to do here to begin with is we're actually just going to say return 0. Now this is problematic. And the reason why it's problematic is because a shape isn't really an object, if that makes sense. It's a concept, right? You can't like own a shape. You can own a rectangle, right, which is a shape, right? but like you can't go and create a shape out of nowhere. Like I can't just go, here's a shape, right? I can create a rectangle, I can create a square, I can create a triangle, but I can't just create like the concept of shape. If that makes sense. Like another explanation would be like, you well, I mean, that's probably the best example I can give off the top of my head. But like, I guess you could say you can't create a country, like the concept of a country, or you can't create like the concept of, I don't know, love or something like that. Like, you can't create like a concept, but you can like create an implementation. So like, you create like America or Australia, right? Like that's an implementation, if that makes sense. Um, and so typically, this shape here, there's a few ways we could do this. And so the first way we could do this is probably what you guys would do in something like C, which is basically where shape kind of represents all possible shapes, right? So there's no inheritance, there's none of that, there's none of this like rectangle extends shape junk. It's just a shape. And so what you may define on that object is you may define multiple things, such as like, for example, a width and a height, right? Which maybe not all shapes have, right? Or you may have like a enum, or some kind of type property, which we're going to say is int, and then you'd have a bunch of hash defines saying like type circle is 1, maybe another one, it's a square is 2, and so on, right? And so the key thing about these is that you're just creating a bunch of like, you're kind of like making this class do everything, and it's a lot of work for the class, and it leads to a lot of redundancy. Unions can help with that, but that's a 1521 if you ever do that. And so inheritance is effectively grabbing what is unique to this class and keeping in the class. And then everything that isn't unique, we're pushing down further down the chain. And so what we can actually do is we use a thing called an abstract class, right? An abstract meaning like an abstract concept, right? And so what this means is that we can't go and create a shape. Like we can't create a new shape because it's abstract. It doesn't actually like have a constructor. Well, that's not true. It can have constructor, but we can't like create it using the constructor because obviously we'll need to like initialize this color. So for example, we can create a constructor here for like, its color, and we can do like this dot color, right? And we can go and we can define a static main void function, arguments, right? But if we try to do something like this, we'll run into some problems. And because it's abstract, right? So even though it's got a constructor, the reason we have a constructor is for our derived classes or our children classes to implement, right? And so that we can still initialize this object, right? So this is kind of where, when I was giving the example before about the shouter, right? And we had a init function in C, right? And so we had two things. We had like I talked about how it basically became a malloc, or like a creation function that allocated the memory, followed by an initialization function, right? And so what this means is that we can still have an initialization function in an abstract class, right? We just can't create the memory, right? If that makes sense. So we don't really use main void function. So what this means is that anything that inherits from us needs to implement this function. So if I look at the rectangle class, immediately I see two things. I see it needs to implement get area, and it also needs to obviously define a constructor. The reason why is that there's no default constructor for shape. And so this is where we run into a few interesting things, and this is kind of important, especially for, well, it depends how we're doing assessments, but we're doing assessments based on your lab, so it's less important. But in the final exam, this could definitely pop up and has. And it's all around like what we call default constructors. So a default constructor effectively looks like this, right? It basically does nothing. So nothing gets initialized, nothing happens whatsoever, right? It's default. And that's what happens if you don't specify any constructors, right? So shape will be initialized to its default value, or say color will be initialized to its default value, which will be null because string is a class. If it was like an int, it would be initialized to 0. Basically, everything just becomes like the default value, if that makes sense, from like a C perspective. But as soon as we define a constructor like this, we lose this default constructor, right? And so if I look at this now, it's just going to warn about the get area. So that's one way we could do it. This is not a good way though, because we still want to be able to initialize this color. So instead, the better way is to basically just define a constructor within rectangle that calls the super constructor. So we'll add the unimplemented methods and we'll also add the constructor, as we can see here. So the first thing that we can see, we can view these comments, is that what we've done here is we've got a rectangle constructor that takes in a color and then calls its super constructor. Now, this is basically saying, hey, go and construct the object that I inherit from because it has some special properties that it needs to initialize. So this is basically an initializer, right? This does no allocations. This is what I was showing about like last week, right? So this is just initializing the shape aspect of this class. And so there's a few interesting things about this. For example, if we implemented a printf here, or this out, and we said inside shape constructor, and then we did the same thing inside rectangle. Super technically has to always be the first line. Like you have to construct your parent before you can use your object. This is a weird consequence of basically the fact is that for rectangle to be valid, its super must also be valid because it implicitly uses its base class. So you always have to initialize its base class before you do anything else. Inside rectangle constructor. And then we can get the area here. So obviously we need more to just a rectangle than a color. So we can define a width and a height. Can I do this? I can. Awesome. And then we can go distort width equals width. Distort height. Comma is just basically saying create two properties of the same type. I guess we'll just do it on separate lines just for clarity. The area is just going to be width times. Right? Now, the key thing about this is that we have this override property here. Now, this is purely just for the compiler to give you helpful errors. So there's a few cases that come along. And the first case that's pretty common is that you override a method that can't actually be overridden. And I see this almost every time with toString. So people will write a toString function like this. And what they'll do, sure, we can say super.toString, is that they will define a toString method that looks like this, but then what they'll do, actually, no, it's more common for equals, so we'll do equals. So if we define our equals method here, equals takes in like an object, not the class. So what you have to do is you have to, for example, we'll learn about this in later weeks. You have to check if the object is null. Yeah, it's called an annotation. So if the object is null, we don't do anything, and then we have to check if the object can be casted. The class equals this get class, right? So you can do various other things like this, where we're saying, hey, the classes have to be the same, and then finally we can actually cast the object. Cast. Right? And this is converting it from this type to this type. Right? And now this is what your equals method has to look like if you actually want it to work. But what a lot of people do when they're just starting off is they'll define the equals method like this. Now, in my opinion, this still should be valid. I think it's kind of ridiculous that Java doesn't allow you to do this. But the key thing here is that when I do this with override, it gives me an error. If I don't add override, it doesn't give me an error. And the reason why is because in Java, all methods are virtual, which means all methods can be overridden, right? And furthermore, every definition is an overriding definition. So what this means is that this override keyword doesn't actually do anything. So if I remove the override keyword from this, it's still actually going to override it. It's just that this makes sure that it always overrides it. So in a case like this, it's going, hey, this override isn't actually doing anything because equals isn't actually going to be overriding anything. So it's like a safety check, if that makes sense. It makes sure that there is a super method called equals. That's it. That's all it does. And so it's warning me here saying, hey, there's no super method that takes in this parameter. That's all it's saying. And so if I change it to object, it now suddenly compiles. So you should always add an override to every method that you're overriding because it makes sure that you haven't done a boo-boo and like gone the type definition wrong, which happens. So for example, let's say you think get area returns a float, right? Like now it will tell you there's a problem, right? Oh, well, this is probably not a great case because when you're overriding methods, overridden methods cannot differ by the return type. They can only differ by the arguments. So if I give it like an extra argument called like scaling factor, this, right, times the whole thing by the scaling factor, we'll see that we get the overriding error, right? Whereas if we just define like this, we won't. And so basically just always add it, if that makes sense. Okay, so I'm pretty happy with this so far. We'll just look at one or two more parts of it, then we'll move on. But effectively, we're just going to write main function, and that's it. And we're going to look at a static function as well. So the first thing we're going to look at is we're going to look at building a static function that returns a red shape, for example, a red rectangle rather. So this is quite common. Now, I have a preference for preferring, in most cases, using a static function over a constructor, right? And the reasoning why is that static functions have nice names to them, whereas constructors do not. And so it's very hard to tell what constructor you're actually implementing, or rather what constructor you're actually calling, I should say. Whereas with this, you have a very nice name that tells you exactly what's occurring. And so, for example, if this was just a constructor like this, right? And it would not look like this, it would instead have to look like this, right? And then this. Actually, you could just do this. This is kind of a nice trick. So you can call the width this constructor, and this basically just will find a constructor that verifies this. So basically just saying that this constructor calls this constructor. But regardless, so we could do something like this, but this is very unobvious that this creates a red shape. And so what it means is most likely going to lead to problems, right? Someone doesn't expect it to be red, or someone changes it to be blue, or something like that, right? Now, in reality, you probably don't want to do something like this, but like this is why I hate these kind of questions and why we're doing a different question in a second, is that sometimes they're very abstract, and so it's kind of hard to like give good reasoning about why certain things are bad because of how abstract they are. There's so much separation between you and it. So if I create a rectangle here, key thing about how I create the rectangle is I have to create it based on the 10 by 20, sure. I have to create it based on the class here, right? And so what this means is that I asked it to create it based on the type rather than an instance, because the static binds to the type, yeah, rather than the instance of a rectangle. So for example, I can print out the area of the rectangle, right? If I run this, I will get, and the key thing here is it goes inside the shape, then inside the rectangle. Now, let's say we come along and we go, okay, we want to define a shape. So yes, a square. We go, a square is basically just a rectangle. I guess we just do this, right? We go, oh, a square is just a rectangle with some extra steps, right? The square has a color. It also has a length. That's really it. So it just goes, super of color and length. Now, the first thing that you got to be a bit careful of, length, is that in OOP, it's very easy to abuse OOP, right? It's very, very, very easy to abuse OOP. And so when we're writing classes like this, we want to be careful about how deep our nesting is, because typically if you have a very deep nested dependency graph, so for example, shape, a rectangle is dependent on shape and squares dependent on rectangle, and it keeps going, it kind of expands very rapidly. And the analogy to this is kind of like virus spreadings, right? So obviously, like things like COVID and stuff, right? You know, it gets very. The reason it spreads so fast is because if 10 people spread it to 10 other people, right? Which is a very high R factor. Um, then what's going to happen is it expands exponentially because those 10 people will also infect 10 people and so on, right? And so the same things happen with classes. If each class has multiple extensions from it, like let's say every class has 3 children, right? And all those children also have 3 children, then it becomes very, very big and very, very complicated and very, very hard to reason about exactly where everything's located. And you get basically a really complicated graph or tree. And so typically, the preference is to use things called interfaces, right, to define logic to basically define like a contract that classes have to abide by, right? So interfaces and abstract classes are great because they're very simple and they're like the top of the tree, but you shouldn't always just go, okay, a rectangle is the same thing as a square, or rather I can implement a square using a rectangle, therefore I'll just do this, right? Instead, a simple way you could do it is you could just have a constructor here, right? That would return a rectangle for a given width, right? That's an easier way to do it, right? Now, currently I can't modify width and height. If I wanted to be able to modify width and height, it actually introduces another problem to this. And this problem is something called Livkov, or this thing's Livkov's substitution principle, right? Which is something that maybe you did in 1531. You definitely do this time. You may have not covered it yet. That's okay. It's pretty simple. And the rough idea of it is that if we have a method called like change width, right? Um, width, and we just like this dot width equals width, right? And then we have another one for height. I mean, you could also call it set height. Doesn't really matter, right? And then we just do this. Right? What we notice here is that we can change the width and height independent of whether or not it's a square. Now, this is very problematic because it basically means that I could start off with a square, saying that's like 20 by 20, then I could change its width such that it's no longer a square, but its type is still square. And so it means that the important thing that you have to realize when you do stuff like this is that Livkov's substitution principle basically talks about that importantly, I should be able to substitute square wherever rectangle is, and it should always be valid. So more importantly, it's not so much that a square is a subclass of rectangle, right? But square should be a superclass of rectangle. So every single behavior that's defined in a rectangle should also be defined in a square. So effectively, in some ways, you could argue that a rectangle is a square, right? So it could be the opposite way around. So you could say a rectangle extends a square. It's less useful because um, a square has only like one width, right? Where a rectangle would have two. But you could define something like that. Um, and so that would be okay. And the reason why is because I could replace every instance of my square, my program with rectangle, and still have it work, right? But I can't replace every instance of rectangle with square, primarily due to this, the ability for me to change the height and width independently. And so it's important that when we realize stuff like this. And so for that reason, instead, this could just inherit from shape, right? Um, and then it would just have a shape constructor like this, and then it could just have a private int length, right? This dot length equals length. And then it could implement its get area, and it could just return length times length. Right? And so that we're no longer breaking livcovs, right? Everything's well defined, everything's happy. And that's basically all I really want to cover around this. I don't think the rest of it is that relevant. That was, I think, even more than what the Tute covered. If there's any questions about that, please ask. While I kind of swap over to my other system. Give you guys a few seconds. Okay. Everyone's happy? I'll move on. So what we're going to look at now is we're going to look at creating a question bank. Now, the reason why we're doing this is because your first assignment will almost certainly use JSON. So I do want to expose you to JSON beforehand. Um, and we'll have a look then. But for now, I just kind of want to roughly go over what JSON is, roughly how to use it, and also the question bank itself will use a lot of this. The question bank will use a lot. I'm just going to quit Slack. I'll just keep getting notifications. And so the question bank will use a lot of the properties that we look now with inheritance and interfaces, but we won't really look at too much depth in interfaces because I don't think it's that relevant, but we will look at abstract classes. So the key thing about here is that we basically have a question JSON file, which is a schema, right? So this basically defines our multiple choice bank. We have 3 questions here. We have types, which define kind of what type of question is. Is it like a multiple choice question? Is it, or in this case, it's a select question, which is multiple choice. That's fine to find. We're going to do project partner at the end of the tute. But basically, all I'm going to do is at the end of the tute, I'm just going to be like, hey, if you got a project partner, tell me now. Else, if you don't, I'm just going to randomly assign you with someone. Then what I'll probably maybe even do is just use BB Collaborate's like group feature where you can like chuck everyone in a room of 2 people, and then I can just like look at the number of groups, and that's your groups. But I feel like that's kind of messy if people already have groups assigned. So I'm not sure. I think I'll probably just like go down the list and pair up people who want to be paired up. It is up to you to define the group though. So once I give you a group, that's okay. You can get assigned to that. But if you want to find your own partner, make sure you do it quickly and let me know. Send me an email. Don't just create the group because I do need to also register on my side because that's the way I keep track of who's in which group, which is a little bit easier. Okay. So we have other things here, such as the question, whether or not it's multiple choice. We have 2 variations. So variations are just going to be randomly chosen. Like, I guess you could also do logic to make it like an easy quiz and a medium quiz, but in this case, we're just going to randomly choose them. And then we just have a bunch of options, right? And so with multi-select, you'll be asked which options you want, and you supply every option, with a comma in between them. And it just verifies that the list of options is correct, right? So in this case, apparently there could be multiple answers to this one. I would doubt it. But you could add other options as well. For example, you could do things such as like possible options. And then if you really wanted to go a bit crazy, you could even have stuff like correct answer. Right? And so the correct answer would be 3. Right? In this case, we're not going to be doing correct answers and stuff like that. Because it's a multiple choice bank, right? So you'd have a different program that would mark these questions. I mean, you may want to put the schemas in the same place, but I just think just keep it simple, right? Now there's other questions here as well as text, right? And text has a length, right? So there's some uniqueness between this stuff, and this is actually like something that's probably like pretty good for OOP, which is one of the reasons why I chose it. So I'm just going to open up a new window just so I can chuck the schema file on the other side of my screen because it'll be easier for me to be able to keep being to refer to it. And I'm going to kind of give you a rough overview of where did it go? Oh, yes. I'm just going to give you a rough overview of I don't know what I'm going to call it, like JSON, I guess. Yeah, sure. So in this case here, JSON's basically defined as a dictionary, right? With like arrays inside of it as well. And so the first thing that we notice here is that this is basically an array. So it's indicating that there's multiple sub objects. And then these are each what we call JSON objects, which are basically like, I guess you can think of them as like classes, right? In reality, they're dictionaries or maps, right? I mean, if you don't know what a dictionary or map is basically just a way to, map a key to a value, right? Which is all that it's doing. It's just mapping a bunch of keys, a bunch of values. Just like in a dictionary, how you have a mapping between words and their definition. And so, for example, go up on my screen. And so, for example, the mapping here is multi-select is true. You can have another mapping of more objects. You have mapping of arrays which contain objects and so on. Everyone else here. Okay, yeah. Okay, so there's other things here too that we can look at later, but right now that's the rough ideas that you just have this mapping between the two. Be careful. The only thing I want to encourage is that everyone's going to be doing 50-50 because you'll lose marks if you don't, right? So we do scale the marks and people have gone 0 before because they didn't do anything. So it's not just an easy ride. You have to do more than just show up. Okay, so we're going to begin by basically just reading in the JSON file. So we're going to do this try for resources thing that we did last time, where we grabbed an input stream, right? And so this try for resources is basically just going to grab the stream. We're going to point it to our questions file. And then it's just basically going to open it, right? Now these will both have to be imported. And if you just like rewrite it, if it pop up, then press enter. Often, oh, it just popped up. Okay. Often it's easier than trying to like remember the name for things. Okay. And so it's complaining here about us not handling exception. I'm just going to add this. Don't worry about this for now. But what we're basically just saying is that this thing can have a problem and it can raise an exception. An exception is basically just something went really, really wrong and we can't easily recover from it. So we need to have some kind of exception to be able to handle it. There's nothing more to it other than that. And so in this case, you can just ignore it and just pretend it is what it is. So the next thing you have is we have a JSON tokener, which is basically like a tokenizer, and it's just going to look at all our tokens and perform our JSON strings so that we can pass them into actual objects. So we can basically convert them from text into objects that we can use in various different ways. The next thing that we're going to do is we're just basically going to grab our array here, right? Because as we notice the very top here, it's an array. Yep. And then we're just going to complain again because I need to find an array, but we can just import that like so. And then finally, we're just gonna basically just print it out. Now we're gonna give it indent factor just to look nice. So when we run this bit of code here, it will execute, as you can see, and we get the exact same thing that we put in, we get back out. Yay, awesome. Now the one thing you'll notice is that the order is different, and that's kind of what's really important about JSON is that the order is not specified. And especially in Java, it changes a lot because of the libraries that we use. And so here the order was name, type, options, then variations. But up here, oh geez, it's variations, name, options, type. So like basically none of them are in the correct order. And so on. And it's most likely due to some kind of hashing or something is the order, because that's probably what it is using underneath the hood. Anyway, you can Google that if you really care and look at exactly how exactly this tokenizer work. You can probably also go to the definition and see the code, as I can see here. We couldn't find the source. That's okay. So what we're going to do next is we're basically now going to just pass this into our actual types. So we're not going to do too much. We're basically just going to get to generate questions and ask to fill in the answers, and then just basically generate a JSON file representing those answers, and that's it, right? So it's going to be pretty quick. We already have a JSON question bank. We'll add that stuff later, but the one I'm thinking of is a question factory. Now, a factory is basically, it's a certain pattern that you'll learn later on. And the whole idea of it is that you can create objects. And the one thing we always want to avoid in, especially in Java, and I'm going to create an abstract type for question 2. My head's thinking fast, I can type. Abstract question type, we'll come back to this. And so the one thing that we want in Java is we want the ability to basically be able to do things like, for example, create questions based on the JSON data, right? And so we can see here that this JSON data has this type. And so the question that we generate is going to be a class that's based on this type here. Now, effectively, that's going to create a bunch of statements. So I'm going to use a switch statement, but same idea. And so we want to basically hide that logic as much as possible because it's not very good to expose that to our program. And the main reason why is because it's just not very scalable, because every time we add a new type, we're going to have to add it to this if statement here or the case statement here. And so it means that we're having to make multiple changes in our code base. And so we want to try to restrict those changes we make to just one place. And so this is going to be the only place that creates questions based on the object file. And that's it, right? And so what this means is that if we go make changes, we're just making in one place rather than hundreds of places. There's other reasons we use this pattern, but this is the simplest way. So we're going to start off by getting the type. This is just a method that we can use. And we give you JSON code. We typically give you for your assignment a basic structure that has a lot of this in it. So you won't have to do that much JSON work. You have to do a little bit, but not that much. But for your final project, you'll have to do quite a bit, typically. They are changing it this year, so it's kind of hard for me to say, but in previous years, you have to do quite a bit. So basically what we're doing is we're just reading from our object here, and this is the object we have. We're just going to read the name and the type. And then we're going to switch on the type and say, hey, if the type is select, then we want to do some custom logic. If the type is text, then we also want to do some custom logic. And then we're going to basically have what's called an else case, so in this case, a default. And if it's default, we're going to throw an exception, the unknown type. Again, don't worry about exceptions. Just pretend that they basically are just like an error message that you would type in C. We'll find later on that they've got a bit more to them. But for now, just pretend that they're just error messages. Awesome. And so now we have these two types here. We're going to have to construct these types, which means that we're going to actually have to create code to construct the types, right, to put it simply. But before we begin with that, we need some ways to map our question, right? And we want to bring as much behavior into the question as we can. And so we can bring variations into the question. So the actual variations can be stored within this class and can be managed by this class, right? Completely, right? Because we don't really need that stuff in the subclasses. So we're going to create I'm just going to chuck the name of the question in here as well, right? Might as well. And then we're going to do a few things, but the basic idea is that we're going to allow you to create this question. And I'm making this protected just because I basically don't want anyone, I mean, it is abstract, but I don't really want subclasses from like, with abstract classes, you very rarely need a public constructor. Let's just put it that way, right? So I typically just define it as protected out of habit because hopefully that makes sense why we don't need it to be public, because I can't construct the object anyway. So I'm only using initialization method. So I only do that inside other classes, which means I can only do it in subclasses. Now the next thing here is we have a list. A list is just like an array, but it's growable. And more importantly, this list here is generic. Now the way I typically code is I just create like a bunch of classes like this, then I'll fill them in as need be. So I'm going to go and create a class, and it creates the file for me, and then I'll come back to that class later, right? And this is going to be an abstract class. And so we have a list of variations here that are being loaded from the file using the factory, right? Because every variation may have custom configuration, so we can't do it generically. And then all we're going to do is just initialize our properties. But the first thing here is that with our questions, we probably want like some kind of mapping that holds like the name of the oh, okay, we don't need this right now. So I'm not going to do this right now, but I do want to show you something cool that you can do with streams, because I think I showed you guys streams last week. And they're pretty cool, but like I don't necessarily think we had some great use cases for them. There were some great use cases that still in the lab. A few people had some, but in the Tute there weren't that many. And so the cases I'm thinking of is, for example, if we actually want to make this a proper application, we want to have like a map type that maps between the name of the variation and the actual variation. And the reason why is that when we want to like load the answers back into the system, we want this mapping that allows us to detect what variation has been chosen, to load properties about that variation. So for example, loading like the correct answer and stuff like that. And so what we're going to do here is we're just going to create a new hash map. Now a map is just what I said before, a dictionary. It's basically just this. Right? We're mapping between a key and a value. The only difference is that we're specifying what the key and the value is. And then a hash map is just an implementation of that. And for the same reason, with lists, a list is like a generic interface, right? It just describes what a list is, but isn't itself an actual concept, right? It's abstract, right? And so when we want to create a list, we'll have to create an implementation of that list. And there's many implementations of list. And a classical case would be an array list, right? An array list is just an array that expands, just like a list, right? There's other ones too. For example, there's a linked list, right? As most of you know. And so the whole point of Java here is that we can use a linked list and an array list, but we can just choose which one we're using at the time of creation rather than having to change it all the way through our program. So this thing here doesn't care if it's an array list or a linked list or a doubly linked list or whatever, right? It doesn't care what type it is. It just cares that it abides by the contract specified by this function. So we have this variation mapping here, right? And we want to load it. Well, a good case here, right? And another case would be that we want to have like just a list of the names, right? Whatever reason. There's a few good reasons here, and the reasons I could think of would be you wouldn't need both of these. You could just do this, right? Which may or may not be better. And so, for example, we could grab this from the variations. So we could start a stream from the variations. And this is kind of similar to what you guys saw last week with arrays.stream, I think, is the function I used, where you can create a stream from an array. In this case, we can just say dot stream because this is like a list and has a generic dot on it. That basically allows us to create a stream from the object. And from this, we can do many things, just like what we did last time. So we could add up all the items, but in this case, I'm going to map it, right? And so what I'm basically doing is I'm going to change what value is currently stored in this. So it used to be a list of variations. Now I want to create a list of strings. So to define a mapping, basically just going to do this. I don't have a getName function, do I? I thought I'd made one. Let's define one because we also need our name for our name. And then we need to create a variation. Create the name. And create a getter. And the key thing here is that you'll see I'll use very little setters whatsoever because setters are not a great design pattern. They're not really a design pattern. They're not a great thing to use. And the reason why is because the whole point we're creating classes here is to hide behavior and hide implementation detail. So if you just let people come in and change your data, then you're not really hiding anything. You're just basically adding extra layers and making the code more complicated, which is why Java gets a bad name, right? Because people just do stuff like that. And so, for example, here we'll see there'll be no way to create a new variation or add a new variation, and there'll be no way to get a variation. All you'll be able to do is get the number of variations and generate a prompt, right? And arguably this list here could not even be a list. We could just pass an JSON object and have this thing pass it. I think that's a bit more complicated though. We're just going to map it to names. And so what we'll see is that by the end of this, if we try to like run this, I don't know why it's complaining. Oh, because we need this. We'll see that it's saying, hey, I've got a stream of objects and you want me to convert them to a stream of lists. I can't do that, right? In actual fact, it's a stream of strings. I don't know why it's saying it's a stream of objects, but you can see here it's going to be a stream of strings, right? And so what we're going to do is we can collect all these objects up together without the semicolon there. And we're basically going to create them into a list, right? And so what we're doing here is we're basically grabbing all the names and then we're creating a new list consisting of only the names. And that's really awesome, isn't it, right? We basically took something that would be like a for loop and you would have to add each name one by one, and then we kind of made it much simpler. And you can do even more complicated stuff, right? like variations, for example. The names here are kind of bad. I'm going to call this variation map. And so for a variation map, we basically just want to do the same concepts, right? In this case, we can just go straight up to a collect, right? And we can say collectors dot map, right? And when we convert to a map, we have two things. We have saying that tells us what the key is going to be and what the value is going to be. And so for each of these, the key is just going to be the name, right? And then the value is just going to be X, right? So we do something like this. And so what this is basically going to do, am I missing a token? I added one too many. Okay. And so effectively, it's going to grab the entire stream of all the list of variations, as we can see here. And one by one, it's going to go through them and add them to a map, right? And most likely this map is going to be a hash map, or I don't know what the default type is. But it's got to be something, right? It probably says somewhere here, because map is very generic, so it will have to be something. We can see it, there's a map here, right? So we could specify the exact type by doing this, but I presume it's a hash map. Maybe there's various different maps. If I go map here, I can see that there's it'll be a binary map. I don't remember the name for the binary map. It's like, I don't remember it, but there's various different ones. You can scroll down and find all of them. But there's a binary tree one. This is an awful search. Like, what the heck? Anyway, so there's many of them. There's hash maps and stuff like that. Anyway, so that's kind of past what I want to talk about, but I still think it's kind of cool and kind of shows off how powerful this stuff can be. It is obviously a bit scary. But I will say that this is one of the parts of the course that we cover really, really late. So we cover basically streams like week 8, week 9, and I think it's too late because by then you've basically done the project, or not really, but you're almost done, and you kind of really don't have much things that you can use with it. So I think it's cool to show off early, and for those people who want to use it, they can use it and they can try it out. Right? You have to read a bit and Google a bit, but those who don't want to use it don't have to use it. Right? It's just an example. So what we're going to do here is we're also going to expose the name. Same reason that we expose the name on the other class, right? The name is something that we do want people to access. And then what we're going to do is we're basically going to define a protected abstract class, protected abstract method called maybe answer question. Actually, I think I was going to call it prompt originally. I don't like that name. And here we're basically going to say randomly ask question or ask question. Right? And so we're going to ask for them to give us a random number generator, right? If you know C, if you remember from C, there's it's called rand, I think. And you like modulus by your upper limit, and then you like add your lower limit, I believe, roughly, or something like that. I would have to like sit down and look at the code again. Yeah, that's what you can do in C. In Java, it's much easier. So we just grab the next one by just saying rng.nextInt, and then we can say, okay, what's our upper bound? Well, upper bound is going to be the number of variations we have, right? And then all we have to do from here is just basically grab that variations for next. That's it, right? I mean, once we have our variation, we'll have to do something right with it, right? But at least we have our variation here. And then we have this thing called ask question. And more importantly, when we ask a question, we want to ask a question with a variation. So what we're going to do is we're going to say return ask question. Also, the other thing about Java is that most of the variable names should be uppercase. So function names should be uppercase. I will most likely forget that. Actually, oops. Just because I often write in other languages like C# for my job and day-to-day stuff like C++ and so on. And so typically when you write in a lot of languages, you do make mistakes because like you think one thing is available in one language and it isn't and so on. So if I make typos, or I call a function name wrong or slightly lowercase and stuff like that, here and there, ignore it. And for the same reason in your exams, I will also ignore one or two style mistakes like that as typical. That's pretty average for us, right? So for example, if some reason you accidentally, you are also in a similar situation where I'm just going to remove imports I don't need, where you also, like, using other languages, you checking other courses and you make mistakes that are small stylistic mistakes, then I will also ignore them as expected. So we have a question here for the select question, right? And we're almost done. This won't go more than another 10 minutes, basically, because at this point, there's nothing much more to do other than reading in the rest of these properties, creating the classes, and then we're done. In cases like this, we also need to probably create a select question variation, right? And so a select question variation is also going to be a class. It extends a question variation, right? We're going to add a constructor that takes in a name and calls it a super name, and that's basically it. Now, there's other things about a select question that we care about. You notice that each variation has a list of options, right? I'm just going to say these list of options are, oh, there's also a name. There's two names here. This is like I guess you could call this is the variation name. This is like its title. So I'm actually going to make that small change. I'm just going to call this title rather than name, just because I think it will make more sense. Here, for the iced coffee question, and for microeconomics. I don't know. I'm really bad at coming up with examples, so I just wrote whatever I could think of. And so when we have this set question here, we're basically just going to have a name, but also we're going to say every question also has to have a title, right? That kind of makes sense to me. So we're also going to pass the title along to the parent. Right, and we'll actually use a toString method to do most of this stuff, right? So this is kind of what I'm talking about, how I'll do stuff like this where we're still going to cover the same content, but it will be a little bit more hands-on in terms of the stuff we'll be doing. And it'll be more relevant to your exams and stuff like that. If you don't want me to do stuff like this, just let me know. You can email me if you want. But typically, most people prefer it. And so we have a title here, right? And so now we want to define our toString method for this. And the easiest way to do this is to say toString. Here's our toString, and we can just return this dot title is our toString method, right? Because this describes the question. Now, in reality, with toString methods, one of the things that we want to do is we want to return a representation of the object, right? Which basically means that we want it so that we understand what the actual type is. So very commonly, we'll add the class name in front of it, right? And so, for example, it's very dark. I'm going to go turn the light on. I am not like a bat. I need light. Interesting. So, for example, we could do something like get class name, for example. And so this would be some way to like kind of signify what kind of question this is. In this specific case, instead, what I'm going to do is I'm going to define a method. Why not? I'm just going to say I'm going to like have this like type passed in. It's like a friendly type name. I'm going to prefix it with, right? So it's the same kind of concept, right? And so this is basically what we're going to prefix it with, and we're just going to do something like this, right? So it's going to like say multiple choice select or whatever, right? And so, for example, for our select question here, one of the things that we notice about select is that we have this multiple choice option that we're also going to load. And so when we create a select question, there's a few things that we care about. And the first thing obviously is going to be this extends a question. And well, I guess an a question variation needs like I should call it question type, which is like the type of the question. If that makes sense. just because it will read a bit better rather than be the type of the variation, which doesn't really make sense. I guess technically they're the same thing. Anyway, and so when we create this variation here, we can just say, you know, whether or not this is multiple choice enough dependent upon the parent. So we'll get to that in a second. Anyway, so one thing that we need here is this. We'll create a constructor. We'll create implement methods. And then we have this ask question thing. Basically, what we're just going to do is create a while true loop, right? Create our variable that we're going to read in. We're going to have to create a scanner as well. So why don't we try to do that as well? Using our try resources trick that we talked about before. Right, and we're going to read it in from system.in. Then we can shift all this stuff forward and let our scanner. Awesome. Okay. And so we can just prompt our user pretty easily by doing a system.out. Say, hey, this .toString, and that's basically all we have to do. That's all I'm going to do, right? And then we're just going to have to also do variation to string, right? And maybe we add like some, I don't know, maybe we're doing like multiple lines or something, who knows? And so this class here, when we go to string, we will just override it here, to be honest. I'm going to say like return or I shouldn't say multiple choice, multiple selects. Like, can you have multiple answers, right? We will not implement multiple select though. Maybe I guess we could. It's not that hard. And then we just need to have a private boolean, and we can just do this dot select equals multi-select. And then we can just say, hey, if this is going to be, select multiple answers, or it's going to be select one answer. And for this question, this toString method defines this object pretty well. Right? There's different ways you could do this. Again, we could talk about adding the class to it and stuff like that. It depends what you're using it for. In this case, it may be best to, instead of using toString here, to actually use some kind of like get human readable version. So we have a function. The reason I'm using toString is just because it's relevant for your lab. In reality, it probably is better to have like a public string get prompt string. Cool. That's I'm happy with that. And so we have this get prompt string function here, which would be like an abstract function that our classes could implement, and they could return like a sign that's much more typical, right? Because really, toString is typically meant for debugging, really. It or like logging or stuff. It's very rarely always meant just for like a human readable. Okay. So if I select here, the only other property that we have to care about select is multi-select. And so what we're actually going to do is we're going to simplify this because I do value time, and we're just going to basically put multi-select out in the open here. It just will save us a bit of time having to like not bother with the passing inner object stuff. And for the same reason, we're just going to say options is 10 here, which arguably I would say max length is 10 here, for the exact same reason, which probably could actually be, instead of being on the variation, probably could just be here. Okay. I guess it doesn't really matter where you put it. That's the whole point of these classes, is that it's flexible. And so with our question factory here, we can just load in Boolean is multiple. Okay, is multi-select, and this equals object.get Boolean select. Right? And then we can just say return select question if I don't remember what needs, what does this function require? They're not defined one yet. There's one defined. Name multi-select variations. Awesome. So the name would just be name. And we also have like multi-select and variations. And so multi-select would be this. For variations right now, we'll just do an empty array list. And it's going to contain about the array list. So we're actually just going to give it null and be really lazy. Okay. Because we'll fill this in a second. Now the break is not needed and we're basically done. And we're going to do the exact same thing with text, right? But for text, we're actually going to say return null because I don't really want to waste too much more time. And so because text will be the same idea, right? You're just going to kind of implement another class that does the exact same thing. And so here we have this class here, everything's okay. We can ask the question by printing out the line, which is going to include the variation, basically select multiple answers, select one answer, list all the variation, list all the options for that variation, right? We can see that this basically just asks the question like this, and then all what will happen for our select variation, which is kind of the point of this. I'm going to ditch this concept. Just because I think it makes this code. And so we're going to do here for the variations, just basically list all the properties. To string, then obviously we need to store the options, which should be done by 15 pass, which is quite nice. And just import the list. There we go. And it's just going to say we can use a very nice method here called string.join, which is basically allowing us to join a bunch of things together. And we're going to join it with commas in between. We need to say options, right? They're going to be all of our options, and more importantly, we can call our super.toString, right? And this is kind of really important, is that you always want to call your super2string, right? And so obviously here, the super2string isn't relevant because this is like the base class. As we can see here, there's nothing it extends from. But this class here, since it extends from question variation, we should call the super2string so that we get the question name followed by all the permutations. And we can like maybe write something nice, so saying like possible. Wonderful. We have really nothing else to add other than this is all we need here. Again, this probably called the parent. I'm not going to make it called the parent. Instead, actually, I'm not even going to use toString here. I'm just straight up going to the toString and just, yeah. Some of you may not know what this thing is, this question mark thing. If you have questions like this, again, feel free to ask it. So what the question mark is, it's what we call a ternary operator. It's basically just like an if statement. So we're checking this condition here, which is multi-select. And if it's true, it's going to choose this option, right? If it isn't true, then you can go, oh, well, I'll just do the other one, right? And so this always resolves to a string every single time. And so we can put some brackets, parentheses around it just to kind of signify that. And so it's either going to be multiple choices or one answer. Easy, and all you got to do is just read the next line. And then we just go check if the line's a valid option, right? Right now, I'm just trying to handle, I guess we got to handle both. So if it's multiple selection, then we've got to create like an array of strings. This. Line.split. Commas. And then basically for each option, we just have to verify if it exists. And again, we can use our wonderful stream here. We can grab all the options, put them in stream, we can see that they all have to match a condition. And the condition is simply put just that possible permutations exist within this variation. So we can maybe have something like variation dot is valid. Is this a valid option in this variation? Now the key thing is the multiple choice is not per variation, it's for the entire object as a whole. So this code here, it being multiple choice, should be here, it shouldn't be within the variation. So we could have a function here called like is valid, right? And you could do it here. It's like a generic one. Boolean is valid and okay. And then here, all we have to do is just return true or false, basically by just saying, hey, whether or not option store includes. It includes, it contains. So if the option contains our option, we just say yes. Doesn't mean we have to go back and change the definition. Okay, so the key thing here that we can take away, which is actually kind of important. Yes, Snarly? No worries. Okay, so the key thing to take away here is that we're not exposing the list. The list is entirely private to this class, right? And so all we're exposing is operations that perform on this object. So if we want to change what this list is, it's very easy for us to define how we store these options and how we manage them. So, I mean, even better, we could just take in like we can make this generic, or we can make it take in an object, right? They this could be any option, right? So we could have like integer options and all this kind of stuff, right? And they don't learn about saying code generics, which solves the same kind of problem, but without having to have this object that's like not very safe. It could be anything, right? We can like specify exactly what it can be. So here we're just going to say whether or not X is valid. And so if they all match this condition, it's good. But if any don't match that condition, so I guess we could say if any don't match this, so if this is false, then what we can do is we can return like some, we can kind of basically give you an error and then just loop again and say, hey, you basically have to, we can just say like sys error, say invalid option, and we'll ask them again. Okay, and then for not multi-select, it's much easier. We basically just have to say else if this condition is true, rather it's not, is valid. Now the key thing here is I'm actually gonna go extra trim because I don't like any white space to have a problem with it. And then we're basically just gonna arguably this is a bit of code duplication that we probably could avoid, but it's okay. And at this point, we're just going to store the result as line. So if everything else is good, then we can just return line and we're done, right? So there's nothing else that we have to do for this question. When we're choosing which question we're going to do, we've done all that logic. All we got to do is load in the variations and that's it, right? And so if we go back at our factory, we're currently not loading in variations. And so it's pretty easy for us to load in variations. The one thing I am going to do is just delete the text option, just because as I said, I don't really want to do that right now. I think it's, you can extend that if you want, but we don't really have time. I don't want to waste any more time. And so for our question here, question factory, we're not even question bank. We don't need it. It's probably nice to wrap this behavior inside a question bank, but again, it's just an example. All we're basically going to do is go through every variation which is inside this array here, as you can see here. And for every variation, we're just going to load the variation, as you can see here. And so to do that, all we're going to do is just define another method. We'll get question variation adjacent object, and probably also throws an exception. Nah, actually doesn't need to. Okay. So the first thing it needs to do is take in the, is there even a type with it? What even is in it? Okay, that's easy. Okay. And so it just has this like random property here called easy. I don't know. This is kind of a bit weird to do it this way, but this is fine. What's probably better is to basically just do this. You want to give each option a name. Just that's like what we were going to store in our system. We don't really want to store the title because it's a more like the title may change over time, whereas the name shouldn't. Okay. So now we can just do this. Review. Um, oh. And then again, we have to do the same kind of thing here, which is annoying. Grab this. We're just going to say name is coffee. I don't really know. This did run overtime. Slightly underestimated the time here. That's okay. And so we're just going to give it name, title, and options. And so as you can see here with the options, most of them in this case is just a list. So we're just going to load another array. Now in reality, the question variation is going to depend on the type. So we're just going to say get question variation select, right? Say, hey, just load the select one. Now this code could probably be a bit better. So we're actually going to make it private. You know, we don't really want to expose this outside this function, right? And so therefore all we're going to do here is just load an JSON array. It's called get an array for some reason. And the array is just going to be called variations. And getting closer and closer. Then all we're just going to do is for each object, we're just going to create it and chuck into a list. I don't know if I can create a stream from a JSON array. I don't believe I can. No, I can't. So instead, we're just going to do the old fashioned. We can create a list of strings, right? Or say a list of variations rather. And we can call these variations. And then all we're going to do is we're going to say equals new array list. So array list is like an implementation, as I said before, right? The actual instance of it. And we'll just chuck it in. Right. Okay. So now we have array list, we have our variations, and we're looping through it. And so all we got to do is just loop through everything in the array. And so it's going to be a JSON object by the array. I believe I can just do this. Not going to be nice to me. I'm going to have to like do a get loop. Oh, well. Unless it's saying it's just an object. Oh, it's just an object. That's okay. We'll just do an object, and then we should be able to class this object to JSON object. Equals JSON object. That's because they want it to be more generic, because it could be like an integer or it could be anything, right? So we're going to say variations. Add, I think it's called. Yeah. And we're just going to say question variation select, giving it an object. Easy. Okay. And then all you'll do back here is just give the variations. So then all variations need to do is you just need to load the options, which in this case is just as you can see here, a series of, well, I guess it's not there because that's the old version. It's just an array of strings. So we're just going to get an array of strings by this. And then we're just going to say, I believe, I felt we could just convert it to like a list pretty easily without much effort, but I may be wrong there. Yeah, to list. And then we can just say, well, this is to list. We'll just grab it as a list of options, objects. And we should just be able to cast this pretty easily to a list of strings. Issues. Leave that cast is valid. Can I cast from object? Because contravariance. Yes. Okay, you can't do that. Even though it's technically valid in this case. So instead, what we'll do is we'll just say, basically, it's like a map through it. That's kind of awkward though. There really is no two-string list. That kind of sucks. Why? I guess we just go leap through then. Okay, so let's create a new array list of strings. And then we'll just go through everything in the JSON array and just basically add it to the thing. And so this for loop, actually, you may have not seen before. I did the same for loop down here. So I'll just show n. And so how the for loop basically works is it's like a for each loop. It will iterate for every object in this, but as having to do like int I equals 0 and so on, it kind of just figures it out, which is quite nice. We can say options dot instead of options, it should be object dot get JSON array of options. Okay. And so it just like figures out what the value should be based upon what it is. In this case, it's a JSON array, so it has an iterator method on it, and it kind of figures out from the iterator method that determines exactly how it should behave when we do this loop. And so rather than having to count up to it, the maximum elements, which as you can see here, that's a length, right? We can just kind of do this very nice method. And that's effectively it. So all we're going to do now is just go return new select question variation. We wrote a lot of code today. And I do not remember this thing needs. It needs a name, title options. That may be possible. Problem with this is that AsList takes in a variadic set. So it takes in like a series of arguments like this, where it's variadic. So you would have to do like a spread. I don't know if spread operators work in Java. Could perhaps do it, but I'm pretty sure even if I do this, I'm just gonna get a list of JSON arrays, as you can see here. But if I convert it to like to a list of this, even if I ask it to create a list of strings like this, it will maybe AsList doesn't even have like generics on it. Anyway, it's still gonna create my list of objects here. I could try to like force it, but I'm not gonna be able to make it spread. And so what's gonna happen is you can see here, it's just creating a list of a list, right? So I'm gonna have to like spread it out so each element's like one by one. Because that's kind of like the point of this. I don't think you can spread it easily. I could convert it to an array. Perhaps. And then once it's an array, I could cast it easier because arrays are a little bit easier to cast, but it's still not the same thing. So I don't think you can do that without having to spread it out. As list is really just like an easy way to create a list if you have like a bunch of constant strings. It's not really that generic. Okay, variations there. I'm happy. I'm just gonna write a very simple CLI. It's gonna load the file, it's gonna print it back out. Then all it's gonna do is just say for every question, for each question, can they? I was not aware. If they can, that's fine. So if they can, that's fine. And it should be okay. The only problem with that would be whether or not it's detecting. So if I did something like this, it would be here, it would be up here. Would be whether or not it would detect as whether or not it would be smart enough to realize what's going on. If I convert it to I'm not going to be able to convert to array immediately. I'm going to have to go to list to array. Also, this performance of this thing is going to be terrible. Like the fact that I'm making like a double allocation here, that's just awful. If I create the as list here, oh yeah, it is. It's just creating a list of objects. So it is smart enough to do it. So I should be able to just like specify the generics here and it should be fine. I could specify the generics as at, but it was not compiling. Like this, I do not remember how generics is specified in this. Okay, doesn't matter. But there should be a way to specify the generics in a special way. If you can't specify generics for a function call, you should be able to. Unless you got to do like this weird thing where you got to do it this way. Yeah, okay, I was right. So it's this way. Yeah. That's a really weird syntax. All right, so if I look at this, it's going to give me an error here because it's not applicable. So I still run into the exact same issue, even though it's an object array. Right, and the problem is that I've got an object array and it wants it as a string array. So I'm still going to have that contravariance problem. I believe it's contravariance. Yeah. And it's not going to let me fix that. So I'm going to have to like do this weird stream thing. And also this is just really, really bad. Like so terrible. Anyway, I get too sidetracked. So our COI is here. We're just going to go for each object in the array, which is each question. And then for each question, we're just basically going to pass the question and then tell it to, that's it really. I don't know, there's not much else you have to do. After you pass it, then ask for the answer. We're just going to grab the question for our object, just be able to cast. And if I haven't made any mistakes, which I don't think I have, there's a lot of code, so I guess maybe. And we're just going to be lazy. Again, ignore exceptions. They're just because it's kind of hard to write Java code without them. We're just going to load our question like this. Then for each question, we're just going to prompt and ask the question. And the way we're going to ask the question is by also getting a randomly generated question. And we're going to initialize our random RNG equals new random. I'm going to have to import the random. It's probably under Java util. Yeah, but I just didn't want to guess. Awesome. Okay. So then that asks us the question. Oh, can I say randomly ask question? Awesome. That's even easier. I don't remember what I wrote. And then we're just going to print this back out again. And we'll be done. There's nothing else you have to do after this. As long as it works. If it doesn't work, and I don't want to spend any more than like probably 5 minutes debugging it. So it's hope it works. So if we're running this, it's going to have to compile it. Oh, look, it works. It prints out. Select multiple answers. What is life? We have endless, perpetual, 42, and Frankie. So we could say 42, comma Frankie, and then maybe comma cats. And it's going to valid option. Select multiple answers. What is life? Again, this probably could be formatted a bit nicer, but hopefully most of you can understand. So if we say like JJ, it's going to fail again. If we just give one answer, it will succeed. No such element, no line found. That's fun. Where was that? Next line, 1651. Wait, no, I can't read 21. That's kind of interesting. Like, who's next line? Should be fine. I'm gonna rerun it. Again, we got 3. And again, so for some reason it's failing on the single options. Theoretically, it should be fine. Oh, I know what's potentially wrong. Multi-select is like something like null or something. Because how it works is when we load it in as a Boolean, potentially. And so what could be happening is if it doesn't exist, it's could be failing. So I'm just gonna add it and see if that makes it work. Rather than bothering with the other option. Oh, I got more like false. Oh. That should be false. stuff like this. And same thing with this. This could just be true. That's not going to be the problem though. For each object, I mean, it should be fine. Really, like it's not doing anything unique. It works the first time, for example. It prints out a question, fine, and then no such element exception, no line found. I'll give it a quick Google, see if it. Maybe I'm like implicit adding a control D. I know you have to check the next line for scanner, but like it should just wait with it. What could be happening is I'm closing standard in by doing this, right? And so by closing standard in, the second time I ask the question, it's the standard in is closed, which means that for some reason it's like closing the global standard in. You know what? That's probably it. It does not close standard in, and instead just keep it open. Even though it's going to complain about it, we'll just see how this works. Because I have a feeling that's what's wrong is it's when it's closing standard in, it's closing the stream, which means it's going to be closing the input stream. Yep, that's it. And so by closing the input stream, it means that the future requests fail. We still should be able to close it. Like that's kind of weird that for some reason that closing this is actually going to close the input stream in like a bad way. There's no way for me to really open it. That's kind of weird. Yeah, I don't know. I've never really. Yeah, I guess it's just always going to get that error. I mean, most people probably found the same error when you started with it. But obviously it's returned, so it's not going to do anything. But if we set it to null here, for example, the error won't go away, or maybe it will. Yeah, it's just going to complain here that it's not closed. So we're just going to have to acknowledge the fact that it's not closed. Maybe we add like a line here saying you shouldn't close a scanner on system.in if you are expecting. The other option would be to use like a static variable or something crazy like that. But like for whatever reason, for some reason with the scanner, it's a little weird. If I close it, it tries to close the input stream, which it probably shouldn't, because the input stream should probably be owned by whoever creates the input stream. But for whatever reason, I think they decided to do it that way. Anyway, so it works, as we can see. I'm pretty happy with that. We'll end it here, unless anyone's got anything else. Yeah, it's very. I've never faced that before. I guess I've never done this before where you're having multiple, well, like it is kind of weird design wise to have this thing have its own scanner. Like what may be better is to pass the scanner in. Just like design wise, it's kind of weird to keep like opening resources that are just like exposed to this, but like it's not that bad. And I don't know. I think it's fine. It's very odd. I would never expect the scanner to try to close it. Anyway. Well, I mean, there's plenty of cases where you do want to have multiple scanners opened, right? Well, I guess the reasoning behind it probably is also that scanners aren't probably don't guarantee threaded behavior, right? So if you do have multiple scanners and you're using them across multiple threads, you do have probably problems. So it's probably better not to anyway. It's still very weird. I know. Anyway, if you have any questions about that, feel free to ask us. We'll just move into the lab. The lab this week is pretty good from memory. Oh wait, it's Tute2. It's lab 02. Probably not. Lab. Okay, that's such a weird name for it. Yeah, but that doesn't that's not going to fix the issue. You are correct. That is the better way of doing it, and the reason why that's better for those We don't 100% know is because the problem here is twofold, right? So the first problem is that the reason I was getting this problem is I was calling next line and there wasn't actually a line available. And so this would check and make sure there's a line available, right? But it's not going to fix the issue because if I close the scanner before I return, like for example here, or if I use a try for resources, whatever, right? It's still going to close the input file, which means that next time we open, the input file is going to be closed and this is going to be false. So we won't get an exception crash, we just won't be able to answer the question. Oh, now it thinks that this loop could terminate. I'm sorry, but like the fact that this loop can terminate is kind of insane. Like it thinks the loop will, actually can terminate. That has next to be false. I'm wrong. So this could return null. I was like, what? It's going to loop. Okay, that's good. And then I can just make CLI load and just show you what I mean. So if I run this now, what will happen is that it will quotation marks work, right? It won't crash, but it won't be great. So for example, if you're gonna ask me a question. I guess not. Is that because the has line? Has next line? Maybe. It should be the same thing. Like we're really asking if it has anything, which should be arguably the same thing as if it just has one. But maybe it makes a difference. Maybe like has next doesn't actually like pause it. Yeah, it's still pausing here. I don't know. That's kind of weird. I guess we could just like run it in debug mode and then see like and pause it. I don't really want to go too much into this, but the lab this week, there's project partners. We're going to do this right now before the 7 p.m. And then we got the exercise here, which is pretty close to what the tute is. The actual tute, if you look up that from the, there's a video obviously. And also it'll be in the code. So in the actual code I gave you, there's this section called work, and you can look inside this, and this has solutions with comments and stuff like that. So as usual, if I skip something from the tute, I'll include it and I'll talk about all the different things of like equals and stuff. I do believe equals isn't in this actual thing, is it? Oh, there is an equals method. Okay, so I'll briefly talk about equals. But it doesn't really matter. So if I pause this here, oh, I think that's kind of weird. It requires like an input. Anyway, so if I give it one answer, it then returns null because it fails. Oh, I know why it requires an input. So this is actually wrong for two reasons. The first wrong problem is the has next line is going to wait until we give it a line, which is why it's pausing and not giving us any text output, because it's going to wait until there's a line or until there's control D or some kind of EOF. And so since it's wait for a line, it's not going to print this printout. So that's the first issue, right? And the second issue is it doesn't actually solve our problem, as we can see here, because once we've closed the scanner, we're still going to run into the same problem that we had before, right? Where it's closed and the next time we open it, it's not going to do anything. Anyway, so the solution is just to not close it and just to cope with the fact that it's going to throw a warning, or to actually make your code a bit better and pass it in as an argument. Anyway, so we have employee here, and I'm just going to create two rooms for it. But effectively, the only thing that's somewhat difficult about this lab is the equals method. Custom assignment, you can move around, and we'll just create a quiet room. You can just stay in the main room if you're just doing the questions. You could also do that. I don't love using it in a global. I would prefer just creating in the main function and then having the main function. Like, I don't know, kind of having the main function pass it through is also ugly, but like, yeah, I don't know if I love a global resource either. Yeah, but I understand why people would do it. Well, I guess with the global is that you're still not actually getting the async behavior from it. So you could make like a singleton that like wraps it around for mutex. Okay. So I've got an Excel document open up on my other system. And I'm basically just going to give yeah. I don't know. I guess it depends, but I'm just going to kind of randomly associate groups. If you have a group, please can you tell me now? Don't move to other rooms yet. I'll move right back. Or I'll just tell them to move back. Okay, so if you have a group, please post it in the chat now. If you don't have a group, then don't post anything, and I'll just assign you a group. I'm gonna stop sharing so I can move across. No worries, Azim. I'm gonna ignore you, because obviously. Okay, so we have a first one, which is